So James Hamilton here again to do another activity development assignment for my adult education class. Today what I'm going to show is how to teach other adults to explain the way that sunlight works to other people. In this case, I'm going to use an experiment that shows people what a sunrise or sunset would look like using a glass of water, a little thing of milk, a spoon, and a flashlight. Now, what you can actually use this demonstration is to help explain to people how the radiation from the sun actually works. Now, the way that the experiment would start is, at first you would shine the light through the water, and as you look at it, it might be hard to kind of see here, but it kind of looks like the sun actually looks like in the sky. Now, this is an excellent opportunity to explain to whoever you're trying to teach this to about scattering. Scattering occurs when the radiation from the sun, light, ultraviolet light, other types of radiation, bombards the earth. Scattering is what happens as it hits the earth. And what it is how the sun's radiation, light, ultraviolet light, and other aspects actually interact with the particles or large particles of gas in the atmosphere. What it does is it causes the electromagnetic radiation to occur, and it will actually scatter out the different wavelengths from the sun. The amount of scattering actually depends on the wavelength of the radiation and the amount of particles or gas actually in the atmosphere. Also the distance that the radiation has to travel. There's actually three types of scattering. The first is Rayleigh, R-A-Y-L-E-I-G-H. Particles in the atmosphere are small compared to the radiation, and it causes shortwave radiation from the sun to scatter more than the longer wavelengths, and the longest of the wavelengths is actually blue, and that's actually why our sky is blue. And the first part of this experiment, as we put the light through the water, kind of shows what the sun looks like actually in the sky. This changes at sunrise or sunset because of how far the particles have to travel. Because the sunrise and sunset are, from our perspective, at the far ends of the sky. Light has to travel further, and that's what gives us the more reddish look. You also have MIE scattering, M-I-E. It occurs when the wavelengths of radiation from the sun and the particles in the atmosphere are about the same. This generally occurs on overcast days. It's kind of what gives us that grayish tint to the sky. You also have non-selective scattering when the particles or gas in the atmosphere is actually larger than the wavelengths from the sun. Makes everything scatter more equally, and what makes fog look white and clouds look white. So let's see how this looks. We put a little bit of milk in this glass, and you want to stir it up. And what you do is you'll put we put the milk in, we stirred it up, and then we put the light through this, and what it should give us is kind of that dusky look from the sun. And it'll look kind of what sunrise or sunset looks like. Now, this is not the same phenomenon that actually causes why we have the sunrise or sunset. As we talked about earlier, it's because of the length that the wavelengths have to travel. But this actually kind of demonstrates some of the other types of scattering. And the reason that we have this particular effect is because the light is interacting with the milk that's actually in the water, and it's actually changing the color and the way that things look. At this point, you can also use this to kind of illustrate, you can kind of think of these milk droplets as like rain droplets in the atmosphere itself, which will act as prisms, and that's actually what causes rainbows to occur. So the lesson here is that on its own, there would be really no colors, but because the sun actually sends wavelengths of different types of radiation, normally the sky is going to be blue because that is the most dominant wavelength, but that changes at sunrise and sunset because of the length it has to travel. This is also a good opportunity to discuss concepts like the ozone layer, which exists to protect us from ultraviolet radiation that comes from the sun, the more harmful aspects of radiation from space and from the sun. It's also a good opportunity to talk about carbon dioxide buildup in the atmosphere, which causes some of the heat from the sun to remain locked in the atmosphere, which leads to climate change and global warming, though that could be a fairly controversial topic depending on where you live. But what this should demonstrate to whoever you're teaching this to is the way that light particles work and that it interacts with various aspects of the atmosphere. I hope that this has been informative. I hope that it's an opportunity to share this knowledge with someone else and to educate someone else a little bit more about science. I appreciate your time. Have a pleasant evening.